Okay, so this is problem 3-3 for AP Physics C Mechanics. So for A, it's asking you develop an equation that expresses the time rate of change of kinetic energy. So kinetic energy equals 1/2 mv squared. It already gives you v in the question. So if we substitute in v, we get this. And if we simplify this, we get 1/2 mv naught squared minus 1/2 RT. Now this is just your kinetic energy at a time t, but what it's asking you for is the rate of change of kinetic energy. So we need to find the derivative of k. We need to find dk dt. So I need to take a derivative of this. So 1/2 mv naught squared is just it's a constant, so it just turns into 0. The derivative of -1/2 RT with respect to t is -1/2 R, which should be the answer in the back of the book. B is asking you to determine the time t it takes to bring the car to a complete stop. So the car is stopped when velocity equals 0. So all we have to do is take the velocity that it gave us and set it equal to 0. So our velocity, which is rad v naught squared minus r over m, should probably write that bigger, r over m t equals 0. We square both sides, the radical goes away. We move rm over t to the other side, so we get v naught squared equals r over m t. We divide by r over m, so we get m over r times v naught squared. And this should be the time at which the car stops and velocity equals 0. Alright. Moving on to C. C asks you to develop an equation for the acceleration of the car as a function of time t. So acceleration equals dv dt. So I need to take a derivative of our velocity, which is given to us. So I'm going to write my velocity. Instead of writing it as a radical, I'm going to put 1/2 outside of it instead as an exponent. So it's going to be v naught squared minus r over m t to the 1/2. So now dv dt equals, the 1/2 is going to come out front. Actually, I'm going to do it this way. My 1/2 is going to come out here. This 1/2 minus 1 is going to give me -1/2. By chain rule, I have to take a derivative of the inside. V naught squared is just going to be 0 minus r over mt, which is just going to give me r over m. And that should be the answer in the back of the book. On to D. So D asks me to draw a graph of time versus force. So first I'm going to come up with an equation. So I know that force equals ma. Now I already have the acceleration right here. So if I'm looking for force was ma, then I just need to times this by mass. Now my mass here is going to cancel out, and this is going to simplify down to -r over 2 rad v naught squared minus r over m t. So now I should probably find my force naught, or my force when time equals 0. So my force at time 0 is equivalent to negative r over 2 radical v naught squared minus r over m, and then we put in 0 for time. So this is going to just turn to 0, so that's gone. This is v naught squared inside a radical, so the squared and the radical are going to cancel out. So this is just going to be negative r over 2 v naught. So my starting point equals r over 2 v naught. So my equation for my force, as t becomes larger, basically this is going to go to infinity because this is going to get smaller on the bottom and it's going to exponentially go up, and it's going to become tangent to this line at the time at which it stops. The graph should look something like this. And that's it. That should be the whole problem.